Hi, in this tutorial I'm going to explain you how to set up a very simple HTTP web server on the ESP32 and return some HTML content to a client. In our case we are going to use a web browser. Note that this is the continuation of the previous tutorial where we introduced the HTTP Async web server libraries and where we return just a simple raw text message to the browser. So we are going to improve this example a little bit more to do something more useful, but please note that most of the code is similar with the exception of the route handling function. So I'm going to sum up real quick the first part of the code, where we basically include the libraries needed to connect the ESP32 to the Wi-Fi network, and the library needed to start the HTTP web server and to configure it. We're also going to need to declare the credentials to connect the ESP32 to the Wi-Fi network. We are going to need an object of this class, Async web server, that will be used to set up the whole server routes and to start the server. Remember also that this is the port where the server will be listening to incoming HTTP requests, and we are going to use the default HTTP port 80. The setup function, Arduino setup function, as usual, we start a serial connection and we connect the ESP32 to the Wi-Fi network so it can later be reached by the client. At the end, we print the local IP assigned to the ESP after it connects to the Wi-Fi network, because the client, in our case the web server, will need to know this IP to connect to the server. Like we did before, we are going to set up a route and a route handling function that will be executed when receiving requests on this route. In this case, I'm going to call this route HTML because we are going to retrieve some HTML code, but some HTML content. But of course, that you can call it wherever you like, as long as then when reaching it from the client, use the correct route. We are going to listen only to HTTP GET requests. And here we are going to implement the route handling function that, as we have seen in the previous tutorial, needs to follow a predefined signature and that we can declare in line using a C++ Lambda function. So, as we did before, we need to return an answer to the client, and we do that by accessing the send method of this async web server request object pointer. So basically, this is passed to our handling function by the libraries, by the framework itself. We don't need to worry about it. Since we are going to receive an object pointer, we need to use this notation to access the method, and then we access the send method that we use to return the answer back to the HTTP client. As we have covered in the previous tutorial, basically, the first argument we need to pass to this method is the HTTP return code. This is a standard HTTP return code 200, which means okay, everything went fine in the server. We need to return this information to the client, and it's a part of the HTTP protocol standard. As second argument, we need to specify the content type, and this is where we need to change things from the previous tutorial. In this case, we are going to return HTML, which means that we need to tell to the client that what we are going to return to it is to be interpreted as such. Being HTML a markup language, the client needs to know that it needs to interpret it accordingly. In the case of the web browser, it needs to render the HTML that we are going to send to it, because if we return here plain text, basically it would show everything that is here, this piece of HTML, as it is. It would show the paragraph tags included. If we say, no, this is an HTML piece of code, then it will render only this part and render it as a paragraph. Obviously, this is a very simple example. Our HTML is very simple because we are going to declare it and return it as a string. But of course that there are more sophisticated ways of declaring this HTML, such as using the file system of the ESP32, which allows us to write, of course, more complex and usable code. Nonetheless, this is just a simple tutorial for us to see what we need to change to return HTML rather than plain text, so we are going to keep things simple. So, as I've said, this is the content type, and as I've also said, this is the content to be returned to the client. Note, and this is very important, for the ESP32, it doesn't know what is HTML code. Basically, HTML code, or even if you wanted CSS code, JavaScript code, they are all strings for what concerns the ESP32. It's the client that will give a meaning to this HTML code. So basically, if we put here some wrong HTML code, the ESP32 doesn't care. Of course, the client will not be able to render it properly, but this is very important for the ESP32. It doesn't know how to interpret this language, and it's just a string like any other string. As I've said, we could also put here, if we wanted, JavaScript and CSS in the middle of the HTML code, but that would be more complex, and we'll leave that for other examples. So like we did before, we just need to call this server begin method at the end, so the server starts listening to the incoming requests. As told before, we don't need to pull any object periodically because this server async is an async solution. So all the framework will handle under the hood all the complexities for us, and we know that when a request is made to this route, this handling function will be executed as long as the server is running. So as you can see, this is very similar to the previous post. So I'm going to move on to show you what will be returned in the serial monitor. Note that I've already uploaded the code beforehand with my correct Wi-Fi credentials. As you can see here, and this is exactly the same that we did in the previous tutorial, it will print here the IP address assigned to the ESP32 on my network. Yours will be different most likely, so don't worry about that, but just copy it and then open a web browser of your choice. I'm using Google Chrome, but you can use another one. So I'm pasting here now the IP address of my ESP32. Remember that this computer that we are going to use needs to be connected to the same network, Wi-Fi network, as the ESP32, otherwise you won't be able to reach it, since this is a local IP address and it's not, of course, accessible to the outside of that network, meaning it cannot be reached over the internet. So we need to put here indicating that this is the HTTP protocol. As I've said, we are using the default port, the default HTTP port, so I wouldn't need to put this 80 here because the browser would use it by default if no port is specified, but just to show you, if you want to use a different port, that this will work. You can use here another port if you want, just for testing purposes. So, and the route is HTML, like we specified in the code, and now if I hit enter, okay, as you have seen, it just ignored my 80, it removed it because it's the HTTP and the browser doesn't need it. It's the HTTP default port. And as you can see, the browser is rendering the HTML. You don't see the paragraph text from the HTML because we told the browser that this would be HTML. So it will interpret it as such. We can see the source code of the page. And here we go. If we see the source code, of course, because browsers allow you to see the HTML code that is behind the page, you can see here, this is the full HTML that we have returned to the client. And basically it rendered and showed it to us correctly. Of course, that this opens up a lot of possibilities. So you can host a web page or multiple web pages in your ESP32. Of course, that you need to be careful about the size because this is a resource constrained device, but it still allows to do some interesting stuff with this web server solution. One more advanced feature that we are going to cover in the future is serving these HTML files from the file system. It's much better than to write them in line in our code. It's much more scalable. But for now, we are going to keep things simple and start with the introductory tutorials. Hope you have enjoyed the video. Thank you very much for watching.